Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kusharida Birumlan. I'm from class J CDCS 1431C, here to explain you guys about the history of geometry and the use of it in our daily lives. Now let's begin with our first issue. So guys, the first question is, what do you all know about geometry? Yes. Now let me explain to you guys about the history of geometry. Geometry is all about shape, size, and the space around us. It's not just for math class, it's in everything we see and we do. Let's go on the journey to learn about the history of geometry and how it has shaped our world. Geometry has been an essential part of human history for thousands of years, shaping how we build, navigate, and even create art. Let's take a quick journey through its evolution and see how it impacts our daily lives. It all started around 300 before Common Era with the ancient Egyptians and Mesopotamians, who used geometry for practical purposes like land surveying and building structures. The Egyptians, for example, applied geometry to construct the pyramids, while Mesopotamians used it to design an irrigation system. Fast forward to ancient Greece, where geometry was formalized by figures like Euclid and Pythagoras. Euclid elements laid the foundation of geometric principle we still use today. The famous Pythagorean theorem relating the side of a right triangle became one of the geometry cornerstone discoveries. Now, geometry isn't just a subject in school, it's everywhere in our lives. We see it in architecture and construction, even in food. Think of the building we live and work in, or even the roads we drive on. Artists and designers use geometry to create balance and beauty in everything, from paintings to fashion. So whether you're building a house, designing a logo, or just finding your way to a new place, geometry plays a crucial role in shaping the world around us. It's a timeless tool that continues to guide us through both simple and complex tasks every day.
Assalamualaikum and hi guys, my name is Adam Chris. Today is the day. After several days of discussion among ourselves, we have chosen TRX Exchange as our first case for this presentation. So at the end of my explanation, you will gain some general knowledge about the Exchange 106 and mathematical calculation related to that building. Without wasting our time, let's begin. Let's take a closer look at the general information and characteristic of the Exchange 106. First, the construction status is fully complete. The building is located in Jalan Tun Razak, Kuala Lumpur, Malaysia, specifically in the Tun Razak Exchange area. It stands at an impressive height of 445.5 meter, making it the 4th tallest building in Malaysia and the 5th tallest building in Southeast Asia. The structure comprises 106 floors and it's supported by 58 lifts and elevator. Architecturally, it features a modern design with a sleek glass facade, offering a stunning visual appeal. Its purpose is multifunctional, serving as a mixed-use size skyscraper that accommodates office space, retail outlet, and commercial areas. Now, let's explore how geometry plays a significant role in the design of the Exchange 106. First, shape use. Prism. The main body of the building is rectangular prism that tapers as it ascends toward to top. Then, triangles. The facade features tessellated triangular glass panels, adding both structural integrity and visual interest. Third, square base. The building's footprint is square-shaped, providing a strong and stable foundation. Second, pattern use. Tessellation. The triangular glass panels are tessellated, creating a seamless and aesthetic structural design. Lastly, symmetry. The building is vertically symmetrical, reflecting balance and harmony in its overall design. Next, let's dive into some mathematical calculation related to the exchange 106. With this mathematical calculation, we need to find volume of the building. First, we need to find base area. Square base has a side length 50 meters. So just put it 50 meter into the formula. So the formula is area equal to length times width. So 50 times 50 is 2500 meters square. Then we can find the volume. Volume equal to base area times height. So base area equal to 2500 times 445 equal to 1,013,750 meter cube. I just need to remind you, the height I get is from the first slide. Next mathematical calculation is we need to find the number of glass panel. As you all know, the side of the exchange 106 is made by fully glass. So the first step is we need to find the surface area. Formula is simple. The formula is length times height and times 4. 4 is because it has 4 sides. So 50 times 45, 445.5 and times 4. The answer is 89,100. Lastly, we can just find number of panel easily because one triangular glass panel cover its 1.7 meter square. So just put that number into the formula. So the formula is number of panel equal to surface area divided by area of one panel. So 89,100 divided by 1.7. The answer is 52,411. That's it, guys. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shadiqul Husni Muhammad Nasir, and I'm going to talk about my case. My case here is called lemang. Lemang is originated in Indonesia and is also found in Singapore, Malaysia, and Brunei. As similar dishes made from sticky rice in bamboo are common throughout mainland Southeast Asia. Lemang. Lemang is a traditional Malay dish primarily enjoyed during festivals like Hari Raya and other special occasions. It is made from glutinous rice, coconut milk, and salt, which are then cooked in a hollow bamboo tube over an open fire. The history of lemang. The history of lemang traces back to the indigenous people of Malaysia and Indonesia, particularly the Malay and the Minangkabau communities, who were skilled in cooking rice using bamboo as a vessel. The dish is thought to have been influenced by the Minangkabau culture from Sumatra, Indonesia, which has a tradition of cooking rice in bamboo. Over time, lemang became a part of the Malay culinary heritage and is now considered a symbol of celebration and communal gatherings. In Minangkabau culture, lemang or lamang is a traditional food which consists of glutinous rice and tapai that is used in various traditional ceremonies, mainly in West Sumatra, Indonesia. According to Minangkabau tradition, the cooking technique of lemang was first introduced by Sheikh Burhanuddin.
So, thank you Husni for your explanation for the history of the lemang. So, I will be moving on to our next slide. So, basically, as the picture showed, there is a bamboo that being cooked right now. So, basically, the method already been explained by Husni. So, I will just moving on to the lemang. So, basically, lemang is being cut into 18 pieces, and basically, for Malaysian, we all eat lemang with rendang, basically some sort of like our traditional foods for Raya also be eaten with chicken floss or beef floss. So basically, let's moving on to our mathematical operation. As you may refer to the slides, I already make some illustration for the bamboo and lemang. So basically, the information that we've been given is the height of the lemang usually is 35 centimeter, and the diameter for the whole thing for the whole lemang is 5 centimeter, while the bamboo thickness is 0.5 centimeter. So basically, now we'll be moving on to the calculation. So for the surface area for the bamboo with lemang, so we use the formula 2 pi RH plus 2 pi R square. So as you all know, the diameter for the lemang is 5 centimeter, while the thickness of the bamboo is 0.5. So you have to plus both and divide by 2 to get the radius. So as you do all the calculations, you should get 652.2732 centimeter square. Next, we'll be moving on to lemang surface area. So basically, we should only use the 2 pi R square to counting the top and bottom for the lemang, as we know that the sides of the lemang is being covered in the bamboo. So we use the diameter with 5 cm, and the answer should be 39.2699 centimeter square. So now we know both of the bamboo with lemang surface area and also lemang only surface area. So now we can calculate the bamboo only. So basically, you take both of the surface area and you minus them. So basically, we should get 613.0033 centimeter square. So we'll be moving on our calculation for the volume for both. So basically, we should calculate the bamboo with lemang first. So basically, as you may know, for the volume formula would be pi R square H. So we use the same radius from the bamboo with lemang on the surface area. So now we calculate and we should get 831.5403 centimeter cube. And now for the lemang, we use the same formula and the same diameter as above. So we should get 687.2234, and we'll be counting the volume for bamboo only. So we already get the volume for both the bamboo with lemang and lemang. So now we will minus both of them, and we should get 144.3169 for bamboo only. We're moving on to our calculation for the volume over weight. So basically, the common weight for the bamboo should be 40.6 kilogram, and basically we take the volume for the bamboo only and we divide by the weight. So basically, we should get 3.5546 centimeter cube over kilogram. And now we'll be moving on to the lemang. So basically, lemang per piece should be 35 gram, and one piece for lemang we should get, as we know that lemang is being cut to 18 part, and our volume that we already get from above for the lemang only, and we'll be divided the volume to 18 pieces. So we should get one piece only. So one piece should be 38.1791 centimeter cube, and now we will calculate the volume per weight for the lemang. So we take the 38.1791 and divided by the 35 gram. So we should get 1.0908 centimeter cube over gram. So that is for one piece of lemang. We're moving on to our calculation for the price. So as you may know, common price for a whole trunk of lemang should be 18 ringgit. So the lemang usually being cut to 18 pieces, right? So basically, we just divided 18 by 18. So we got 1 ringgit per piece of the lemang. Okay, so that's all from me. Thank you.
So in conclusion, geometry has influenced the world from time to time. Unexpectedly, geometry can be everywhere in our lives, such as buildings, food, furniture, and many more. The uniqueness of geometry can be mesmerizing and could inspire the younger ones to build and create more buildings using this knowledge.